Welcome guys, this is a video from Chapter 7. Chapter 7 is dealing with oxidation and reduction. Well, it's dealing with reactions in general, but in this case we're going to be talking mostly about, in this video, mostly about the oxidation reduction portion of that chapter. So if you look in your book under chapter 7, you'll see information about reactions. So there are several reactions that can be classified as oxidation reduction reactions. And for us, single replacement are always going to be redox. Combination synthesis, always going to be redox. Decomposition sometimes, and combustion reactions always. All right, so the driving force for all these types of reactions is the transfer of electrons. All right, that's the driving force, like what is causing them to happen. So let's look at what oxidation numbers are. They're just made up numbers. They're numbers that are, let's just type this out. They're numbers that are arbitrarily assigned. Okay. They're numbers that are arbitrarily assigned. Let me make this smaller here. Make it about 12. Numbers that are assigned to elements in order to keep track of electrons that are gained or lost during a reaction. All right, so now the rules for assigning oxidation numbers down here, switch over to my pen tool, are as follows. They are the oxidation state of any element is 0. So for instance, Na is an element, so its oxidation number is 0. Oxygen, it's in its elemental form, it's a molecule, but it's in its natural state, so it's also 0 for its oxidation number. Any oxidation state for an ion is equal to the ion charge. So Na plus, 1 plus, is a +1 oxidation number. Cu2 plus is a +2 oxidation number. For the ion charge, we put the plus and then the 1, but for the oxidation number, we put the, for like sodium, Na plus, it's a 1 plus ion. We put the number and then the plus. But for the oxidation number, oxidation states, okay, we put the plus and then the number. It's just a little little rule, a little nitpicky rule for chemistry. If you wrote a +1 ion, people would understand. If you wrote a 1 plus oxidation number, people would understand, but there is a distinction. We have a 1 plus ion and a +1 oxidation number. There is a difference, okay? All right, so oxidation state of oxygen is always 2 minus in a compound, except in peroxides. It should say always 2 minus in a compound. All right, so if it's in a compound, it's always going to be a 2 minus charge. So for instance, here the Na is, well, the oxygen is a -2. Here in the notes, they wrote 2 minus, but it should be a -2. That's okay, right? So this is a -2. Now there's 2 sodiums, so each sodium is a +1. Each sodium is a +1, because +1 times 2 is 2. Over here, halides, oxygen state of halides is usually -1. Okay, I'm just going to erase a little bit of this so you can see it better. Let me try writing that again. That's fun. So in a compound. Okay, and then halides are going to be -1. So this HF, the halide is, the F is -1 and the H is +1. For here, the halide is -1 and the P is +3, because 3 times -1 is -3, so we need a +3 for the P. So P equals +3 and H is +1 here. Okay. And then we go down a little bit further. We said the oxidation state of hydrogen is +1 when it's with nonmetals. So here the H is a +1. Here the H is also a +1 because the oxygen was -2, the sulfur was, the H is a +1. So the sulfur, you have a -2, you have that's times 4, which is -8. Here you have a +1 times 2, which is a +2. So therefore, this sulfur has to be what? It has to be plus 6. You see how that equals out? Negative 2 times 4 is negative 8. Plus 1 times 2 is negative 2. The sulfur has to balance this out, so the sulfur is plus 6. Okay. This hydrogen here is also a plus 1 because the chlorine is, a minus 1. All right. Come down here. When dealing with 2 or more nonmetals, things get a little tricky. So 2 nonmetals, greater electronegativity, more attraction for electrons, is assigned the negative value. The second element in the binary compound is assigned the negative oxidation number except for H. So for instance, the oxygen is minus 2, therefore it's a minus 4 over here because it's negative 2 times 2. So the sulfur has to be a plus 6. Right, so the greater electronegativity is assigned the negative value. I mean, oxygen, right, obviously is going to be minus 2. It says it always. The second element in the binary compound is always assigned the negative oxidation number. So for instance, here we have the sulfur, the oxygen. Oxygen is minus 2. Negative 2 times 3 is negative 6. So the sulfur has to be a plus 6. Here you have nitrogen. Here you have oxygen. Oxygen is minus 2. Minus 2 times 5 is negative 10. 10 divided by 2 is plus 5. Here you have carbon. Here you have oxygen. Oxygen is minus 2. Minus 2 times 2 is negative 4. So the carbon is a plus 4. Here you have nitrogen. Here you have hydrogen. Hydrogen is plus 1. The plus 1 times 3 is plus 3. So the nitrogen is a minus 3. Okay. Over here you have carbon. And you have hydrogen. Hydrogen is plus 1. And the hydrogen times 4 is a plus 4. The carbon, therefore, is a minus 4. So essentially, all I did was I went through these compounds. I looked at the oxygens. I looked at the hydrogens. I found out, well, I know the oxidation number of oxygen is always minus 2. Of hydrogen, it's always plus 1. I found out how many oxygens there were. I multiplied them. 2 times 3 is negative 6. And then I just found out the charge for the sulfurs. Pretty simple. For an ionic species, the sum of the oxidation states must equal the overall charge. So for instance, Cl, oxygen. Oxygen's minus 2. Minus 2 times 3. Now you can't really see it so well, but there is, I'll zoom in here, there is a negative charge right there for that chlorate ion. So the negative 2 is for the oxygen. Negative 2 times 3 is a negative 6. And therefore, the chlorine must be a plus 5. Once this thing slows down, there you go. The chlorine is a plus 5. Here, the chlorine and the oxygen is a minus 2. Minus 2 times negative 4 is minus 8. So the chlorine must be a plus 7 in order for it to equal that negative charge. The sulfur and the oxygen is still always negative 2. Negative 2 times 3 is negative 6. Now this has to only be a plus 4 because there's a 2 minus charge. Hopefully that makes sense. Go through that at a slower pace if that didn't make sense. All right, we have 5 more pages of notes. So assign the oxidation numbers for each element in the following compounds. So oxygen, we'll just write it out like this, H, N, and O. The oxygen is always minus 2. The H is going to be plus 1. Minus 2 times 2 is minus 4. And this is a plus 1. So therefore, there's 3 left over, so this is a plus 3. Does that make sense? Hopefully. Over here, the Cl is just 0 because it's in its elemental form. Over here, we have the Ca, we have the S, and we have the O. The O is going to be minus 2. All right, the Ca is going to be a cation because this is a metal and a polyatomic ion, so the Ca is plus 2. There are 4 oxygens, so negative 2 times 4 is negative 8, and then the plus 2 from here, so that's negative 6 total, and then so this is going to be a plus 6. So equaling everything out. The Al and the Cl is minus 1 because it's a halogen. There's 3 of them, so the aluminum is going to be plus 3. And the aluminum should be a plus 3 because it's a cation. The sodium is a cation, so it's going to be plus 1. The phosphorus and the oxygen, we figure it out. The oxygen is negative 2. Negative 2 times 4 is negative 8. There are 3 sodiums, so it's a plus 3. So this has to be a plus 5 to equal everything out. Carbon and hydrogen. Hydrogen has to be a plus 1. Plus 1 times 8. That's going to be a plus 8. So this has to be a minus 8. Minus 8 divided by 3. Oh, now we're into what we have to say is a decimal oxidation number. So we just do 8 divided by 3. And 8 divided by 3 is 2.7. Negative 2.7, excuse me, because it's a negative 8 divided by 3. So it's a negative 2.7. Let's erase that and make that a little clearer for you. Okay? So it's a negative 2.7. Just touch that. There we go. Carbon is negative 2.7. Where did I get that? I got that from negative 8 divided by 3. Okay, the oxidation number goes Cr to Cr3 plus, loses 3 electrons. So here we have Leo the lion says grr. So losing electrons is oxidation. Gaining electrons is reduction. Okay, so you can look at your lion here. This is Leo, he's a lion. Right? And Leo the lion says grr, and that will help you memorize your oxidation rules. Put some eyes there for Leo. Okay, cool. So he's Leo the lion. There you go. He says grr. Okay, and that's your little mnemonic device. So the oxidation number, if you're losing electrons is oxidation, chromium is oxidized. But if you gain electrons during a reaction, right, Leo says grr, and you can also do oil rig. Oxidation is losing, reduction is gaining electrons. This scantium is being reduced. Scantium is reduced, scantium 2 plus. Right, because it's gaining electrons. It gains 2 electrons. All right. So the oxidation number goes, if you are oxidized, your oxidation number goes up. It's increased. And if you reduction, oxidation number goes down. Okay. So here's some practice. Show the reactions for the oxidation of sodium. Sodium, if in a reaction, if it was oxidized, would turn into sodium 1 plus, and it would have a plus 1 electron there. Strontium in a reaction would be strontium 2 plus 2 electrons, and the aluminum, I'll put it down here, the aluminum in a reaction becomes aluminum 3 plus, and then it's plus 3 electrons, like that. Over here you have the zinc. The reduction of zinc is plus 2 electrons, and it becomes zinc solid. So it's no longer an ion. Over here, this is potassium. Potassium gains an electron, and it becomes, oops, sorry, that's supposed to be an arrow. It becomes potassium solid. Over here, this is iron. If you gain 3 electrons, if you're iron, you become iron solid. You are reduced. You gain electrons. Notice here, when you're oxidized, you're losing electrons. You go from a neutral element to a cation. All right, we scroll down a little bit more. Here we have redox reactions. For every reduction reaction, there must be an accompanying oxidation reaction, so they have to balance. If something loses electrons, something else has to gain electrons. So here, iron is oxidized, it loses electrons, but copper is reduced, it gains electrons. The number of electrons transferred is 2. See, 2 coppers, 2 electrons. So there's 2 electrons transferred. Now this you don't have to worry about. The oxidizing and reducing agent, no longer on the AP. Okay, it's no longer on the AP. It might be on the SAT. If it is on the SAT, I'll tell it to you really quickly. But it's no longer on the AP. But essentially, it's this weird thing that chemistry used to do in textbooks. And what it is, it's like this. It's the oxidizing agent is the thing that does the oxidizing. So copper is the oxidizing agent. And the reducing agent is the thing that does the oxidizing, the thing that gets oxidized. So zinc, right, is the thing that's actually the reducing agent. Here it says iron is oxidized. That's a mistake. That's supposed to be zinc. Sorry about that. All right, and here's the overall reaction. You can see zinc is oxidized, copper is reduced. Okay, here's a little URL. If you type this in, you can listen to some lecture on the movement of electrons, electricity, and how we capture it for the use in batteries. All right, so you can look at that URL right there, and you can see you know, a little bit of, yeah, electricity. Here we have another page, page 3, a little bit of practice. We're not going to do this oxidizing agent, this reducing agent here. I mean, I could, but essentially it's not on the AP, and this is an AP preparatory course, so we don't really need to do it. We'll do a few of these. So here, aluminum, here's how I do this. I put a line from aluminum to aluminum 3 plus, like that. And I say, okay, aluminum to aluminum 3 plus, it's losing 3 electrons. So therefore, loses 3 electrons, it is oxidized, like that. That's how you do it. All right, it's oxidized, you get the aluminum. And then I go over here and I say, well, what about the copper? Well, the copper gains 2 electrons. Copper gains 2 electrons, so it is reduced. Right? So the copper 2 plus gets reduced. Now the oxidizing agent would be the copper, and the reducing agent would be the aluminum. Okay, and then total number of electrons transferred, well, you have to balance this out. So this is an unbalanced equation. So if there are 2 electrons and 3 electrons, well, what you do is you write out the half reactions. Okay, so in this equation, there's actually 6 electrons transferred. Let me show you how I know that. Because I'm going to need to put a 2 here and a 2 here, because this aluminum is going to lose 3 electrons. And then this copper over here, copper 2 plus, plus 2 electrons is going to be copper solid. So in order to make these balance out, I've got to put a 3 here, make that into a 6, like that. And I've got to put a 2 here, that's supposed to be aluminum, and make that into a 6. And now my electrons balance out. So it's a little bit different. We're not going to do these in this class, but when you get to AP, you will do these in your class. So not in our class. All right, you don't have to do those. You don't have to do those. Let's do 1 or 2 more of these. So calcium here becomes a 2 plus ion. How does it do that? Well, it lost 2 electrons. So it was oxidized. Apologize, I put that in blue. And then I'm just going to stay in blue here to save some time. The silver gains. It gains how many electrons? 1 electron. So the silver gets reduced. So the silver 1 plus is reduced. The calcium is oxidized. And there's going to have to be 2 electrons transferred in total, even though the silver only gained 1. Okay, and I will balance these equations out for you. You're going to need 2 silvers in order to balance out the number of electrons. Again, this is not in our class. It will be on the AP. Let's do one more. So here is nitrogen, and this equation is already balanced, so that's nice. Actually, no, it's not. It's partially balanced. So they put a coefficient here for the 2, but you're also going to need a coefficient here for 3. So now, hydrogen is going to be a plus 1 here, and the nitrogen is going to be a minus 3 here. The nitrogen was a 0, and the hydrogen was a 0. So what happened to the hydrogen? It lost 1 electron, so therefore it's oxidized, like that. The nitrogen gains. It gains 3 electrons, so it is reduced. It's reduced, like that. And therefore, the oxidized is the H2 gas, the reduced is the N2 gas, and the total number of electrons transferred, well, there's 6 hydrogens, so the total number of electrons equals 6 electrons, because 6 hydrogens, 1 electron each, that's a 1, okay, is 1. All right, that's about enough of that. Let's look down here at single replacement reactions. So here's your activity series. We went over these in class. We'll just go right into a few reactions. So here's just a little bit of, you can use this tiny URL and you can watch some redox reactions. And you can watch the activity series in action. And here we've got silver plus copper nitrate. So what happens is, if you look at the activity series, you're going to have silver being a precipitate, or excuse me, it's a solid here. The silver turns into an ion. So what happens is you get silver nitrate aqueous, and you're going to have 2 of those. and then you're going to have copper solid. All right, let's just double check that. I think that's the case. Let me check that actually. So here is silver down here. It is less reactive, and here is copper, which is more reactive. So let's look back at that. Now the copper is more reactive, so the copper is a solid. It should be able to give away its electrons. So actually over here, I was wrong. Copper is more reactive, so this doesn't happen. So we're going to cross this out. This does not happen. There is actually no reaction here. There's no reaction. Now, so what about this? We're going to drop solid copper into a solution of silver nitrate. So we're going to switch. The cation is going to become the solid, and the solids become the cation. So now here's a new reaction. So this is the top part is no reaction because the copper is more reactive. All right, so the copper is more reactive than the silver. And so over here now the copper is going to be able to give electrons to the silver. So here I have copper solid, I have silver 1 plus and nitrate 1 minus ions, and over here we get a little pile of silver solid. This is going to turn blue because we're going to get copper 2 plus ions in here, and we're still going to have the nitrate in there. And then here's the balance equation. We're going to need 2 of those. We're going to have we're going to have copper. Let's try to write this out a little better. Copper 2 nitrate, which is aqueous, plus silver solid, like that. Okay. And then let me just double check something really quick. Copper more reactive. Yep, exactly. Okay, so then down here, this is a net ionic equation. Now you can do these complete ionic, net ionic for these type of equations. We did them in class. Let's try it. So here I have the nitrate is my spectator. All right, so my complete ionic equation, let's write it. Cu solid plus 2 silvers, 1 plus aqueous, plus 2 nitrates, 1 minus aqueous, gives you copper 2 plus aqueous plus 2 nitrates, 1 minus aqueous plus silver solid. Okay, like that. Now, the net ionic equation, I get rid of my spectators. So I'm going to get rid of the spectator ions. The spectator ions are the nitrates. So I get rid of those. And over here, my net ionic equation is copper solid plus 2 silvers, 1 plus aqueous, leads to, we'll make that an arrow, leads to copper 2 plus aqueous plus, oops, I forgot to put a 2 here, plus 2 silver solids, and I have to put a 2 here as well, like that. And now the Cu turning into the Cu2 plus, that's oxidized because it is losing, it's oxidized, it's losing electrons, and Cu is the reducing agent. But again, we're not going to do that in this class. Ag plus is reduced. All right, so Ag is the oxidizing agent, but again, we're not going to do that in this class or even in AP. It might be on the SAT, maybe on the SAT Chem. I'm not sure. I'm not sure if they still have it on there. The net ionic equation, the Cu and the 2Ag plus. Now, this is the net ionic equation. We're going to have 2 electrons transferred in total because the copper is going to lose 2 and the silver is going to gain 1, but there's 2 silvers. All right, let's do this one more time here, and then we'll finish up this video. It's getting kind of long already. So here I have, let's just make sure, aluminum is a cation. Let's make sure it's more reactive. So aluminum, I have it right there, and I have magnesium. And aluminum has already lost electrons. So magnesium is more reactive. Let's look back. Oops. Let's look back here. So the magnesium is more reactive. So the magnesium, this will have a reaction. So it will be aluminum solid plus magnesium chloride, aqueous, like that. All right, and then we're going to need to balance it out. So we're going to need a 2 here, we're going to need a 2 here, and we're going to need a 3 here and a 3 here. All right, because there's 3 chlorides like that. You see now you got 6 chlorides on each side. So the oxidizing one is the one that loses electrons. So the magnesium loses electrons. He's oxidized. Here, the magnesium goes from 0 to +2. The aluminum goes from +3 to 0. So the aluminum is reduced. So aluminum 3 plus gets reduced. The driving force, again, we're not going to really talk about that. Transfer of electrons, though, is your driving force. We don't need to do oxidation reduction agents. And there are 3 magnesiums. Each of them lose 2, so there are 6 electrons transferred in total. Try this one on your own, and I'll be happy to do it for you in class. Let's see if we have any more notes here. Okay, combination synthesis, and then at the end we have decomposition and combustion, and then that's it. That's the end of it. So let's do like 1 or 2 of each one. For this one, sodium and water. Now this does have a reaction. Anytime you put a metal into water and it's an alkali metal, you will get sodium hydroxide in solution. And then you will have H2 gas. Oops, sorry, H2 gas. Okay? You have sodium hydroxide and you have H2 gas. And here the H goes from a +1 to a 0. It also is still a +1 here. Over here the sodium is a 0 and it turns into a +1. And the oxygen remains -2 on both sides, like that. Right? So the hydrogen here is going to be reduced. The hydrogen gains. Not all the hydrogen, some of them don't gain, but some of them gain electrons. And I got to balance this out because you got 2 hydrogens here, and you only have 3 hydrogens on this side. So now you have 4 if you put a 2 here. And now here you have a 2 as well, and you have to put a 2 there. Now you're all balanced out. So this gains 1 electron, and there were 2 hydrogens that gained those 1 electron each. So therefore, there were 2 electrons transferred in total. Like that. And if you look at the sodium, there's 2 sodiums. Each of them lost 1. So the sodium is oxidized, and the H is reduced. Okay? And this is a practice that you can practice with these 2 as well, and you can practice with this. This is going from words to equations. So iron solid plus copper to sulfate, like that. And you can see, will you have a reaction? Look back at your activity series on this page, and you look at, 2 pages back, and you look at copper, and you look at iron. Here's copper, here's iron. Iron is more reactive, so if iron is a solid, you should see a reaction, and iron is a solid, so yes, you should see a reaction. So go ahead and try. Write this out, find the number of electrons transferred, find who's oxidized, who's reduced. Do that for these 1, 2, 3, 4 problems. Try that out. I'll answer them for you in class if you need. Okay, combination synthesis. This is if you can either oxidize a metal, which is called rusting, or you could burn hydrogen and oxygen. Those are synthesis reactions. You can even burn metals, like we can burn magnesium. So in this one, let's just do this one. This equals strontium oxide, and it's a solid. Any metallic oxide is a solid. And the strontium is a 0, the oxygen is a 0. Then over here, the oxygen is a -2, and the strontium is a +2. So therefore, the oxygen went from 0 to +2, and the strontium went from 0 to, the oxygen went from 0 to -2, and the strontium went from 0 to +2. So the strontium is being oxidized. The oxygen is being reduced. All right, and there were 2 electrons transferred in total. This is going to be balanced out once we do this. So actually, I was wrong. There was 4 electrons. I messed up almost because I forgot to balance the equation. Make sure you balance your equations. All right, that should be the first thing you do when you see an equation. So I should have done that first. So try that with these, and you can even try the ones. Let's do one of them with words. So solid zinc plus iodide solid. Now this is going, we can do a decomposition reaction for this in class, and I think I did one for you in class using sodium iodide. But here it's zinc and iodine turning into zinc iodide, like that, and that's going to be a solid as well, like a salt. And so here I have to put a 2 to balance this out, and I have to put a 2 here and therefore now we're all balanced. And let's do this. So we have a 0 and a 0, we have a -1 and a +2. So if you go from 0 to +2, the zinc is oxidized. And the I is reduced because you went from 0 to -1. And how many electrons got transferred in total? Well, there are 4 iodines, so 4 electrons total. All right, try those two out as well down here. All right, last page, we're going to do a combustion reaction and a decomposition reaction, and then we're all done. So here, we're not going to do oxidizing agent or reducing agent. If you're going to do decomposition, this becomes magnesium solid. If you're a metal, you become a solid metal. If you're bromine, you become a diatomic molecule, Br2, and bromine's a liquid at room temperature. Look at the periodic table in the room to make sure that you understand that. This is already balanced. Now over here, the oxidation number is 0, but over here it's a -1 or +2. So if you go from +2 to 0, you are reduced. So magnesium is reduced. If you go from -1 to 0, you are oxidized. So the bromine is oxidized. Now, how many electrons get transferred in total? Well, there are 2 bromines. Each one of them loses 1 electron. So if you lose 1 electron each, and there's 2 of you, then there are 2 electrons total that are transferred. Try these couple out. We'll do one of them that's a word equation. Cobalt-2 bromide. Cobalt-2 bromide. Cobalt-2 bromide. Let's say it's aqueous because it has to be aqueous in order to do electrolysis, and I'll do this for you in class. It's going to turn into cobalt solid and bromine liquid, like that. And when we do that, we see that it's already balanced. Here you have the oxidation number equaling 0. Here the oxidation number is +2 and -1. We know that it's +2 because it tells us in the equation, or in the notes here. And then what we say is, okay, well, if it's going from +2 to 0, therefore the who is reduced, it is cobalt. Who therefore is oxidized? It is bromine. How many electrons transferred? Well, there's 2 bromines, and each one of them loses 1 electron, so there's 2 electrons total that are transferred. Let's try a combustion, and then we're all done. So one combustion reaction. This one's a little bit harder, but we're always going to make CO2 and H2O in this class when we burn hydrocarbons. So let's do it. The oxygen is -2 always, and then here it's 0. So it's -2 in a compound always, I should say, and it's 0 when it's by itself. The H in a compound is +1, and then we figure it out. -2 times 2 is -4, so the carbon has to be +4, and there's only 1 carbon, so the carbon is +4. But over here, we have 8 hydrogens, so the +8. Over here, therefore, we have a -8. -8 divided by 3 is going to be 2.7. So here you have a -2.7 for the carbon. So the carbon goes from -2.7 to +4. So if you're -2.7, you're +4, the carbon, you're oxidized. Then who gets reduced? The oxygen. The oxygen is 0, and it goes to be -2, so the oxygen is reduced. How many electrons transferred in total? Well, if you have to balance this out, you have to balance it. You got to put a 3 here for the carbons. You got to put a 4 here for the hydrogens. You have 8 hydrogens, 3 carbons, 3 now 6 oxygens, plus 4 is 10, so you got to put a 5 here. So 5 times 2, 10 oxygens, each one of them gaining 2 electrons. 10 times 2, there are 20 electrons transferred in total. And you can double check that with the carbons. You'll get a decimal. So if you make this -2.666 repeating, and you multiply it times 3, and if you go from, so for carbon, it went to +4 from -2.67, like that. So therefore, that's let's just say 4 and then plus 2.67. So we have 6.67 electrons times 3 is right around 20. Right? It's 20.01. So similar, right? Similar to the numbers with the oxygen. We just lost a little bit because of the decimal. All right, that's it. Those are your notes. Hope they help. I'll get a note packet on nuclear chemistry as well.